Hi, Assalamualaikum. Right. In this video, in this streaming, I'll be doing some revision on the techniques of differentiation. So without further ado, let me just share the screen. Right. Share the screen. Share the screen. Okay. So this is what we have in the previous semesters for the test. But before this, the differentiation for the techniques of differentiation was included in the assessment one, meaning to say that it was included in the task one, but now it's modified a little bit because due to the ODL semester, so this part will be brought forward for the assessment two. All right. So, but never mind. Let's just look at some questions on the techniques of differentiation. So, all right. So, firstly, we should recall that firstly, if we differentiate a number, we'll get zero. Differentiate a variable should give us like we have to bring down and copy, and then we have to minus one the power, and then we have the what do we call that product rule, right? Where we have y equal to uv, so we have to do the differentiation using formula, where the formula is given by y equal to y prime is equal to uv prime plus vu prime, and then we have the quotient rule, which is u over v, so we have the formula uv prime minus uv prime over v square, and so on. Right, and then we have the six techniques for differentiation of the trigonometric functions. So we have the differentiation of sine x, cos x, tangent x, and secant x, cotangent, and also cosecant x. And we have the differentiation for ln and also exponential function. All right, so let's look at this question. So we have this question number one. We have this y equal to this. So we should actually divide this into two parts here. We cannot simply multiply that, all right? So this one is actually u, this one is actually v. So we have to use the product rule in this case, all right? So we know that for question number A, and we have to write u equal to e to the power of sine of 3x. And v is actually given by tangent of 2x minus 3. Right, so something like this. Okay, so we have to differentiate u and also differentiating v. All right, so we'll have something like u prime will be, okay, so we'll have something like differentiating e, which is exponential, will still give us the same function, which is e to the power of sine 3x. But now we have to differentiate the one at the power here, which is the sine 3x. So differentiating sine will give us cos of what? Cos of 3x. We'll just write cos of 3x. But we are not done yet, but we have to differentiate this 3x. Then will give us, actually will give us, differentiating 3x will give us 3. Okay, something like this. So we have to simplify this. We'll get something like 3e to the power of sine 3x cos 3x. All right, that one is for u. Now we're going to differentiate v, so we'll have something like v prime will be, all right, so v prime will be Right, so differentiating tangent will give us secant square. Right, so secant square of what? Secant square of that 2x minus 3. But we are not done yet because we have to differentiate the one in the bracket. So in this case, we have to differentiate 2x minus 3. So differentiating 2x minus 3 will give us 2. Differentiating 2x will give us 2. Differentiating 3 will give us 0. All right, so we have something like this. All right, so we can simplify this to be 2 secant square of 2x minus 3. Okay, so we have done differentiating u and v, so we can now utilize the formula where the formula is given by y is equal to a uv prime plus vu prime. All right, so we have y, sorry, this one is y prime. So y prime is actually given by uv prime. So we have uv prime is actually uv prime, meaning to say that we have to multiply these together. We have to multiply this and this. So that one will give us e of sine 3x multiplied with the 2 secant square of that 2x minus 3 into the bracket. All right. And we have to add together with that one, meaning to say we have to multiply this with this. Will give us, all right, kind of a tangent of 2x minus 3, and then we'll multiply with the 3e to the power of sine 3x cos of 3x. All right, so we have to simplify this. All right, so usually we'll just write number first. So in this case, we'll just write 2 first. So we'll have 2, and then we'll get e of sine 3x, and that trigonometric function will be added back there. Will give us secant square of 2x minus 3. All right, and that one we'll have to write 3 first. We have to write the number first. All right, so that one is the coefficient. All right, so 3e to the power of sine 3x, and then multiply with the cos of 3x multiply with the tangent of that 2x minus 3. All right, so I think we are done here. All right, we can even factorize e to the power of sine x in this case, but I think you can just stop here. So you're done with the differentiation of question for number A. All right, so let's now move to question number B. So we have this, all right? So we know that we have to differentiate this y equal to ln of x squared sine e to the power of 3x, but we have to differentiate ln in the first place, and then secondly, we have to differentiate one in the bracket. But be careful that the one in the bracket is actually the term that you have to utilize the product rule for the differentiation of x squared sine of e to the power of 3x. But in this case, for it is easier for us to simplify this first. All right, before we could differentiate this, we should use the properties of the what do we call ln. So we know that if we have like of ln a multiplied with b, so we'll have actually ln a plus ln b. So in this case, we'll just treat this as a and this part as b. All right, so this is a multiplied with b, so will give us ln of x squared plus ln of a sine of e to the power of 3x, something like this. All right, so this one is easy for us to differentiate. All right, so let me just write the formula first. All right, so B, for question B, where should I write this? All right, let's say I'm writing it here. All right, so let's say B, we have the formula y equal to ln of x squared sine of e to the power of 3x. I can actually move that to that side. All right, okay, so firstly, we utilize the formula, sorry, the properties of ln. So we can actually write this as an addition. So ln of x squared plus ln of sine e to the power of 3x. Okay, or something like this. So now we want to differentiate this. So differentiating this dy over dx. Okay. All right. So firstly, we have to differentiate ln. All right. In this case, differentiating ln will give us that fraction. All right, so we'll have 1 over x squared in this case, 1 over x squared, 1 over x squared. But now we still have to differentiate this x squared, will give us 2x. All right, we are done with the first term. Now we're going to differentiate the second term. Right, in this case, we'll have like ln of that. So we'll just write differentiating ln will give us 1 over sine of e to the power of 3x. Now we have to differentiate that sine of e to the power of 3x, meaning to say that we have to differentiate this part. So differentiating sine will give us actually cos, all right? So differentiating sine will give us cos. Cos of what? Cos of this e to the power of 3x, all right? But we are not done yet because we have to differentiate that e to the power of 3x, right? So you have to differentiate until you get into the innermost function, all right? So you'll have e to the power of 3x, differentiating e to the power of 3x will give us e to the power of 3x. But you're not done yet because you have to differentiate that 3x, so differentiating 3x will give us 3. And then only we are done, right? It's quite long, but you can do this, right? So we'll have something like this, right? You can simplify that x together with x squared. So we'll give us 2 over x, all right? 2 over x. And then we have the, all right, let's say we got that one. We know that cos of e to the power of x over sine of e to the power of x. So cos over sine is actually will give us, using the identity of the trigonometry. So we'll have cos over sine is actually cotangent, all right? So cotangent of what? Cotangent of that, all right? Cotangent of e to the power of 3x, all right? It's not tangent. Tangent is sine over cos, so of course the inversion of that tangent should be cotangent, all right? 1 over tangent is cotangent, all right? So that one multiplied together with the 3e to the power of 3x, right? So this one can be simplified as 2, we rewrite this as 3e to the power of 3x cotangent of e to the power of 3x, right? I think we can stop here, all right? So if you want to make this as a single fraction, you can do this by making the denominator the same. Now we have to multiply with x at the numerator and also denominator. So this one will give us 2 plus, all right, 3 multiplied with this x will give us 3x e to the power of 3x cotangent of e to the power of 3x over x. So this one is for the sake of, you know, kind of more, is much, is nicer, right, to write this in this form, all right? So that's the answer for the B, all right? So now, let's look at question number C. We have this function. So we can't run from the u over v in this case, so we have to use the u over v, all right? So I'll just write u first, all right? So for question number C, u is actually given by sine square of 2x plus 5, sine square of 2x plus 5, sine square of that 2x plus 5, all right? And v is actually given by x plus 1 to the power of 2, right? In this case, this is v, right? X plus 1 to the power of 2, all right? So differentiating u in this case, all right? So before we can differentiate this u, it's better for us to write this a sine of 2x plus 5, put in a bracket, square outside, okay? The square should be outside. All right, so we want to differentiate u now. Okay, so differentiating u, we'll have to use the bracket technique in this case, all right? You can even use your, what do you call that? Chain rule, right? Or substitution here, all right? So you have to bring these 2 in front. So you'll have 2, all right? So you copy everything, meaning that to say you have sine of 2x plus 5 to the power of that 2 minus 1 will become 1, all right? That's the basic technique for the bracket. For now, you have to differentiate the one inside the bracket. You have to consider this function, but you have to consider the sine function first. So differentiating sine will give us cos. Cos of what? Cos of that 2x plus 5. So please put that 2x plus 5 in the bracket. But you're not done yet with the differentiation, since you have to differentiate the innermost function. In this case, you have to differentiate 2x plus 5. So differentiating 2x plus 5 will give us, all right? So 2 plus 0. Differentiating 2x will give us 2. Differentiating 5 will give us 0. So we can simplify this. Actually, we'll have, all right, when you simplify this, it will give us 2 multiplied with 2 will get 4. 4 of sine of 2x plus 5 cos of 2x plus 5. So we have these. All right. So sorry, this is u prime. All right. I'm finding u prime here. Okay. So I'm going to move it here. All right. So now you have to differentiate v. In this case, we have v is given by x plus 1 square. All right. So v is actually x plus 1 square. So differentiating this, still you have to use the bracket technique, right? So you have to bring that 2 in front, all right? So we'll have 2, all right? So copy everything, and then that power should be 2 minus 1 will give us 1. And then you have to differentiate 1 inside the bracket. So in this case, you have to differentiate the x plus 1 will give us 1. This is easy. So this gives us 2x plus 1 in the bracket, all right? So we have this u prime and v prime. We can utilize the formula for the quotient rule, for where the formula is given by, okay, dy over dx is given by vu prime minus uv prime over v square. All right, so we have something like this. So first we'll just write v. All right, so we have vu prime, meaning to say that we have to write this v multiplied with the u prime. So we have something like, okay, x plus 1 square, you multiply with the 4 sine. Right, I'm not going to write multiplication symbol there. I'm going to just write dot, means multiply. Sine of 2x plus 5 cos of 2x plus 5, right? The one is for vu prime. Now you have to subtract the uv prime, all right? So you subtract the uv prime, means you multiply these together. So that one will give us sine of square 2x plus 5 multiplied with 2x plus 1, all right? So this everything should be divided by v square, meaning to say that v square means x plus 1 square. You have to take square, will give us x plus 1 to the power of 4. So we'll have x plus 1 to the power of 4 here. All right. Okay, so we can simplify this. Actually, we can factorize that x plus 1 first. All right. So we note that, all right, I don't want this unicorn color here. All right. This x plus 1, then x plus 1 can be factorized here. All right, so I'm going to factorize the x plus 1. Have something like this. So I'm left with the 4, and we have x plus 1 to the power of 1. And we have that sine of 2x plus 5 cos of 2x plus 5. All right. And then I'm going to subtract with this part has already been factorized in front there. So we're just left with the 2 sine square of that. 2x plus 5. Okay. So we have this over x plus 1 to the power of 4. And then only we can cancel the x plus 1 with x plus 1 to the power of 4 will give x plus 1 to the power of 3. So the final answer for this one should be 4x plus 1 sine of 2x plus 5 cos of 2x plus 5 minus 2 sine square of 2x plus 5. So everything should be, the whole thing should be over x plus 1 to the power of 3. And we are done with the differentiation for question number 3. Question C. All right. So that's it. It's quite long, all right? But you still can solve this, right? Let's try another set of questions. So we want to simplify this, all right? We want to factorize this, all right? Sorry, differentiate this, okay. Now we want to differentiate that ln square of secant 3x. So firstly, before you should differentiate this, you should rewrite this in this form, all right? For question number A, I'll just write ln of secant 3x. Please put in the bracket the square outside. Why? because this involves the bracket technique. So to differentiate this, right? Firstly, we'll have to bring these 2 in front. So it will become 2 multiplied in front. So we have that ln of secant 3x, all right? And then that 2 to the power of, the power will become -1. So 2 minus 1 will become 1. And then we have to differentiate the one inside the bracket, which is the whole thing here. But firstly, we'll have to differentiate ln. Differentiating ln will have got 1 over something. So 1 over this whole thing. So differentiating ln will give us this. But now we have to differentiate that secant of 3x. Differentiating secant first. So differentiating secant will give us secant x tangent x. But in this case, secant 3x will give us secant 3x tangent 3x. But we are not done yet. We have to differentiate the one in the innermost function, which is 3x. So differentiating 3x will give us 3. Yes, it's quite long. All right. So we know that we can cancel this part because they are the same term. So we are left with the 2 multiplied with 3 will give us 6. And then we have that tangent 3x, okay? Well, I'll just write tangent 3x first. Tangent of 3x. And then we'll have this, the one in the bracket. So we'll have ln of secant 3x, all right? So I guess we are not left with anything anymore, all right? So that's the final answer for this one. For question B, you can't run from the U over V. So this is the one that you have to use the quotient rule. All right. So let's just write the U first. All right. So U over V. So in this case, U is actually sine 3 to the power of, sine to the power of 3 of 2x. And V is actually e to the power of tangent 4x. E tangent 4x. Okay. All right. So we have to kind of put this in the bracket so that we will not do any mistake when differentiating this. So sine of 2x, put in the bracket, and the power of 3 is outside there. Okay, so we have to differentiate u. So in this case, differentiating u will give us, so firstly, we have to bring this 3 in front, so it will give us 3. All right. So now we'll just write the whole thing. We have to copy everything, the one inside the bracket, 2x. And that 3 should, this 3, the power should -1 will become 2. Okay. So now we have to differentiate the one inside the bracket, but the one inside the bracket, we should differentiate sign first. So differentiating sign will give us cos. Cos of what? Cos of this 2x. So cos of 2x. Okay. But we are not done yet with the differentiation since we have to differentiate the last term here, which is 2x. So differentiating 2x will give us 2. All right. So we can simplify this. 3 multiplied by 2 will give us 6. 6 sine square of 2x, right? All right. Cos of 2x. All right. So we are done with the differentiating u, right? So now we have to consider the v. So we have to differentiate v. In this case, to get v prime, we have to differentiate e first. So we know that differentiating e will give us the same function. In this case, will give us e to the power of tangent 4x. All right. So we'll have something like v prime is actually e to the power of tangent 4x. But we are not done yet because we have to differentiate the tangent 4x. So we have to differentiate tangent. In this case, differentiating tangent, we know that differentiating tangent will give us secant square. All right, tangent at secant square of x. Yeah. All right, so differentiating tangent will give a secant square of the 4x because this is 4x, not x. All right, so secant square of 4x. But we are not done with differentiation since we have to differentiate this 4x now. Differentiating 4x, we have 4. All right, so we can rewrite this so that it looks nicer. So 4 should be in front. So 4 e to the power of tangent 4x secant square of 4x. All right. So since it is u over v, which is quotient rule, so we have to use the formula for quotient rule, which is given by dy over dx vu prime minus uv prime over v square. So in this case, put into the formula, vu prime, meaning to say that you have to multiply this part, this and this, right? So e to the power of tangent 4x multiply with the 6 sine square of 2x cos of 2x. And then we have to minus the u multiply with v prime. So u is here and v prime is here. So sine to the power of 3 of 2x multiply with the 4 e to the power of tangent 4x secant square of 4x. All right, so everything should be divided with what do we call? With 4. Sorry, v square, right? V square. We should divide everything with v square. So this one should be divided by v square. V in this case, that e to the power of, all right? E to the power of tangent 4x, but we have to square it. Okay, something like this. So now, we can actually factorize that e to the power of tangent 4x at the numerator because we have this. Okay, we have something like this. Okay, so firstly, I'm going to factorize that e to the power of tangent 4x. And then I'll have 6 sine square of 2x cos of 2x minus that one is actually sine cube of 2x secant square of 4x. All right, so everything should be divided by e to the power of tangent 4x to the power of 2. So now we can cancel this e to the power of tangent 4x with that one will become to the power of 1 now. So this one should be, the final answer is actually 6 sine square of 2x. 2x cos of 2x minus the sine cube of 2x secant square of 4x. So everything should be divided by e to the power of tangent 4x. All right. So we are done with question B now, right? I'm gonna bring it here. Okay. It's lengthy, but you can do this, right? Let's try question C here. All right. So question C, if you know that you want to differentiate e to the power of x squared square root of x minus 1, means you have to differentiate e first and then you have to differentiate the power. In this case, the index is actually given by x squared square root of x minus 1. All right. You have to use u multiplied by v. All right. But it's okay. So firstly, right, where I'm gonna write it. Right, I'm gonna write it here. So C. So differentiating this will give us dy over dx. Don't forget to write your dy over dx first. So dy over dx is actually e to the power of x square root of x minus 1. But you can stop there since you have to differentiate this part. Okay. So you have to differentiate that d over dx. Okay, I'm going to differentiate that x square root of x minus 1. But you know that, okay, we know that this part is actually u and this part is actually v. So we have to use the formula where, all right, so this should be e to the power of x square root of x minus 1. So this one should use the formula for u multiplied by v is actually uv prime plus vu prime. Okay, So to do this, we have to find u and v, all right, separately. So I'm going to find u first, all right. So u is actually given by x squared and v is actually given by square root of x minus 1, where square root of x minus 1 is actually x minus 1 to the power of 1 over 2. So we have to differentiate u. So differentiating u will give us 2x. And differentiating v will give us, all right, we have to bring down 1 over 2. We copy everything. We have to minus 1 of the power. So it will give us negative 1 over 2. Differentiating the one inside the bracket will give us 1. All right. So this one multiplied by 1. Okay. So this one can be written as, can be simplified as 1 over 2 square root of x minus 1 actually. Yes. All right. So we know that we have to use the formula where u v prime plus vu prime here. So this part is not affected. So we'll just write e to the power of x square root of x minus 1. And the 1 should be put in the bracket. U multiplied by v prime. Multiply this together with this. So will give us x square over 2 square root of x minus 1. We have to add plus with the vu prime. Multiply this with this will give us 2x square root of x minus 1. All right. So this is your final answer. All right. If you want to make this as a single fraction, you can. All right. Let me try. We want to simplify this. All right. Let's say you want to simplify this. So we have to multiply this part, okay, this part with square root of x minus 1 over square root of x minus 1. So this will give us x squared plus 2x square root of x multiply minus 1 multiply with square root of x minus 1 will give us x minus 1 put in a bracket. All right. So the whole thing, oh, sorry, you have to multiply with 2 here because you want to make the denominator become the same, right? So the one will become 4x square root of x minus 1. Okay, yeah. For x minus 1, so you have 2 square root of x minus 1 at the denominator. Okay, you have something like this. Actually, you can expand this part, right? So that one will become, okay, e to the power of x squared square root of x minus 1. So this will give us x squared plus 4x squared minus 4x over 2 square root of x minus 1. So this can be e to the power of x squared square root of x minus 1, and then that one should be x squared plus 4x squared. You can simplify this, it become 5x squared. So we'll have 5x squared minus 4x over 2 square root of x minus 1. So we are done, right, for question C. All right, so let's now move to another set of questions. All right, I want to discuss another set of questions. Suppose we have this. Adjust this. I'm gonna bring it here. Okay. Allah, drink some water. All right. So suppose we have this set of questions. I think we have done this, right? Ln of 6 square. Yes, just now we have done this, right? This one should not be here. We are done with this one. So which type of question? And I think we have, are we done with that one? Yes, last sine of 2x plus 5. Yes, we are done with this one, right? So let's just look at another set of questions. Suppose I have this. We are done with this one. We are done with this one, right? Let me check. Hoo-hoo, hoo-hoo. Mhm. We are done with this one. Let me just check some previous questions first. All right. Suppose we have this. Okay. How do I copy this? Never mind. I'll just copy this. Put it here. Is it possible? Because this is the MAT type equation. I'm gonna put. All right. It works. So we have this function, right? So we have this function. We want to differentiate. We know that if we have that ln e to the power of sine, okay, uh, try to avoid using the u over v in this case. So we need to simplify this using the properties of ln, where dy over dx is actually given by, okay, we know that if ln of a over b, we can separate this to become ln a minus ln b, all right? So in this case, we'll have ln of e to the power of 6x minus 5 minus ln of x squared minus 1. All right, we have this. So we want to, sorry, this one is y, all right? We have not differentiated yet. So this one is y is equal to this, all right? So we want to differentiate this y. So we'll have dy over dx, differentiating with respect to x. Differentiating ln first. So differentiating ln will give us 1 over this part. It's actually e to the power of 6x minus 5. Uh-oh, is it freezing? But why? You have to freeze now. Hello? Hello?